what we discussed, we will discuss first. First, I have discussed this alpha scattering experiment, and after that we have discussed the distance of the closest approach. Okay, and after that we have discussed the impact parameter. After that we have discussed the drawbacks of Rutherford model, and after that the Bohr's model of atom. Okay, radius and velocity in the orbit we have discussed. After that we have discussed energy in a particular orbit of electron. After that we discussed the energy level diagram, drawbacks, energy level, we have discussed this. Okay, energy in a particular orbit. Now we will discuss the energy level diagram. So first you should see this picture, Bohr's model of atom. So this is a Bohr's model of atom. This is the nucleus. This is first shell, second shell, third shell, K, L, M, N. These are the energy levels. Okay, or shells you can say, or stationary state you can say. So if electron is revolving in this, so electron will have the fixed energy. So if electron is revolving in this orbit, means the electron's energy is fixed. So for first orbit 13 minus 13.6, second orbit minus 13.4, third orbit minus 1.5. After that, energy, we have written energy for n is equal to 1, means in the ground state the energy of the electron will be this. For E2, this is the energy. E3, this is the energy. E4, this is the energy. E6, E5, E6, E7, you can calculate with the help of this formula. Okay, minus 2.18 into 10 to the power is z square by n square. Z is the atomic number, n is the energy number of shell. No, okay, for first shell n is equal to 1, second shell n is equal to 2. Okay. If you want to calculate in electron volts, then this will be the formula. Now, energy level diagram. So energy level diagram is basically we will represent these energy on a particular diagram. So this is the energy level diagram. So for ground state, for n is equal to 1, this is the energy line. For n is equal to 2, Harsh, are you getting my voice?
Yes, sir. Yes, sir.
Okay. For n is equal to 2, this is the energy line. So I told you for n is equal to 2, the energy will be minus 3.40. For n is equal to 3, this is the energy. For n is equal to 4, this is the energy. For n is equal to 5, something will be the energy. For n is equal to infinity. N is equal to infinity means the electron is removed from the shell. Ionization. So when the ionization will be there, electron will remove from the shell. The energy of the electron will become 0. The energy of a
Yes,
electron
sir.
will become 0. Okay, because what is happening now, electron, when the electron in a particular shell, electron is bounded with nucleus, electron have the negative energy. When you will free the electron, means you have given some energy, some positive energy you have given, and that is why the electron's energy will become 0. So this is the energy level diagram.
Yes, sir.
Yeah. After that, there are some drawbacks of the Bohr's model of atom. First, we have seen Rutherford model of atom. Then we have seen the Bohr's model of atom. Now there are some drawbacks for the Bohr's model of atom. So drawbacks for the Bohr's model of atom, 6, I think 5 points I have written in a concise manner. It stands true for the hydrogen atom and hydrogen-like
Yes,
atom.
sir.
So Bohr's model of
Yes,
atom
sir.
we can apply only for hydrogen atom, either for hydrogen atom or for hydrogen-like atom. What is the meaning of hydrogen-like atom? Means hydrogen-like atom means one electron species. The species in the atom
Special.
means you can say hydrogen-like atom means the atoms in which there is only one electron. For example, helium atomic number 2, He helium atomic number 2, and atomic number is
Yes,
equal
sir.
to an atomic number 2. So in helium, number of electron will be 2. But
Yes,
when you
sir.
will remove one electron, so it will become He plus, and He plus will have only one electron. Similarly, lithium 2 positive and beryllium 3 positive having one electron. So on these species, the Bohr's model is true, and for hydrogen also the Bohr's model is true. When you will apply it for iron, any other species having multi electron, it is not valid. Okay, so it cannot explain the spectrum of multi electron species. So for the multi electron species,
Multi-electron
this
states.
cannot explain the energy spectrum. Okay, and
Yes, sir.
one more thing, the Bose model of atom takes into account the particle nature of electron. Takes into account the particle nature of the electron. It is not taking into account the wave nature of electron. That is why it is violating the de Broglie hypothesis. After that, Heisenberg uncertainty principle. So let me tell you what is Heisenberg uncertainty principle. Heisenberg's uncertainty principle means for the electron simultaneously at a point you cannot measure the position as well as the momentum. You cannot measure the position as well as the momentum simultaneously, but according to the Bohr's model we can calculate that. Okay, position of the electron means the radius of the electron we have calculated with this formula. Momentum of the electron we can calculate because we know what is the velocity of a particular electron in a particular orbit. So with the help of velocity we can calculate the momentum of the electron also. So these two we can calculate simultaneously according to the Bohr's model atom. But according to the Heisenberg uncertainty principle, you cannot calculate the position and the momentum at the same time. So it is violating the Heisenberg uncertainty principle. Yeah. After that, it cannot explain the splitting of line in electric field. Okay. It cannot explain the splitting of a spectral line in electric field or in magnetic field. Okay. So basically, splitting of a spectral line in electric field is known as the Stark effect. And the splitting of a spectral line in magnetic field is Zeeman effect. Zeeman effect. So basically, this cannot explain the splitting of the lines. Basically, the splitting of the line in the electric field and the magnetic field. Have you studied the crystal field theory in your chemistry? So basically, there you will see this. Okay. Now, after that, the emission spectrum. First of all, we will discuss what is the spectrum. Then I will come to the emission spectrum. This is a prism. This is a white light, and this white light will split into 7 colors. And if this is the screen, yeah, this is the screen here, and on this screen you will find the wavelength range from 400 angstrom to 800 angstrom. You will get a continuous wavelength from blue to red. Okay, with your from violet to red. Okay, this is violet. So on the screen you will get basically 7 colors. Okay, this type of colors on the screen you will get. So basically in these colors there are all wavelength present from 400 angstrom to 800 angstrom.
Yes, sir.
4,000 angstrom to 8,000 angstrom. So all wavelengths are present in these colors. So this is basically known as the continuous spectrum. This is known as the continuous spectrum.
Continuous spectrum.
Yeah. Continuous spectrum. So in continuous spectrum, on screen you will get all the possible wavelengths from 4,000 angstrom to 8,000 angstrom. Means all types of color which are related to these wavelengths you will get on the screen. But in case of the emission spectrum, now there are basically 3 types of spectrum. First is continuous spectrum, another is emission as absorption spectrum. Next is, so this we will discuss in detail. Okay, and this I will tell you when we will finish the emission spectrum. So what is the emission spectrum? What is the emission spectrum? So emission spectrum, suppose this is the atomic, in this container there is an atomic gas. In this container initially there was an atomic gas, and that atomic gas is heated with electric current. We know that the heating effect of current means with the help of the current we can produce the heat. So here with the heating effect of current, the gas inside this container is heated. Okay, and this gas is heated, so this gas will give the radiation. Okay, this gas will give
Yes,
some
sir.
radiation. So this gas will give some radiation, and when that radiation you will pass through the prism on the screen, you will not find the continuous spectrum. Means you will not find all the wavelength from 4,000 angstrom to 8,000 angstrom. Some wavelength will be missing here. So some specific wavelength were present on screen. Some specific wavelength only were present on the screen. Okay, so this type of uh, spectrum you will get on the screen. This is completely dark. Here is one wavelength. This is completely dark. This is completely dark. Means few wavelengths you will get
Yes.
on the screen, or few colors on the screen you will get. So that is why this is known as the emission spectrum.
Emission spectrum.
Emission, yeah, emission spectrum, or this is also known as the line spectrum, because what is happening here, you are getting all the wavelengths, but here you are getting only few wavelengths. Other wavelengths are missing out. Other wavelengths are missing out. Few wavelengths we are
Yes,
getting
sir.
on the screen. This is known as the emission spectrum. Okay, this type of
Spectrum.
this spectrum will be different for different elements. Okay, or different gases. So every gas has a characteristic emission spectrum. Okay, for hydrogen, this is the spectrum for hydrogen. For if you take helium, then the spectrum will be different. What is the meaning of spectrum different? Means you will get different wavelength on the screen. Okay, you will get different wavelength on the screen. So what is happening in the emission spectrum? Some specific wavelength were present on the screen only. Only some wavelength. You can write here the word only. Only some specific wavelengths were present on the screen. Now, why this is happening? The reason behind it. Okay, just give me 1 minute.
Yes, sir.
Okay, now we will define why we are not getting a continuous spectrum here. Here we are getting a continuous spectrum, but here we are not getting a continuous spectrum. Only specific or some wavelength were present on the screen. Now, what is the reason behind it? So, reason is very simple. Basically, what happens when you will give heat to these gas molecules? So, these are the gas molecules, and molecules are made up of atom. Basically, you are giving heat to the gas atoms. They will absorb some energy, and inside the atom electrons are there, so electrons will absorb some energy and electron will move to the higher energy level. It is or not? Try to connect with me. Okay,
Yes, sir. Yes, sir.
Actually, what is happening? You are giving heat to these gas atoms, and inside the atoms, electrons are there. So electron will absorb heat, and electron
Yes.
will go to the higher energy level. But there is one thing: at higher energy level, electron is unstable. At higher energy level, electron is unstable. So electron will move to the lower energy level, and when electron will move to the lower energy level, electron will release energy or emit radiation, and that radiation is having the specific wavelength, and energy of each orbit is fixed. That is why we are getting the emission spectrum. I have written the theory here. I told you that in the last class. Nucleus, first energy level,
Yes, sir. Yes, sir. Yes, sir.
second energy level, third energy level. Energy of each energy level is fixed. So if the electron is moving from first to second, then it will emit a photon of definite energy. Photon of definite energy. Okay. Or you can see here, this electron is absorbing energy. So if the electron will absorb some energy, so it will move to the higher energy level. Now, if the electron is supposed initially at the higher energy level, so if it is going to the lower energy level, it will release energy. So when the electron will get energy, it will move to higher energy level. Higher, what is the
Yes,
meaning
sir.
of higher energy level? L is the higher energy level with respect
Yes,
to
sir.
K, and M is the higher energy level with respect to L. Okay.
M.
So now see why the emission spectrum is happening. On heating, electron jumps to higher energy level. So when you will heat the atom, suppose this is the atom, this whole thing is inside the atom. So basically, this is you are heating this. So when you will heat this, what will happen? The electron is suppose initially here. This electron will absorb heat from heating.
Yes, sir.
This electron will absorb heat, or okay, or you can say this will absorb radiation, and this electron
Yes,
will
sir.
move to the higher energy level. This electron will move to the higher energy level. But what I told you, the electron at the higher energy level is not stable. So electron from here from here will again move to the lower energy level. Okay, this is suppose this is the N2, this is N2. So when it will move from higher to lower, it will emit photon of the specific energy, and that will have a specific wavelength and a specific color. So you can say electron is very unstable in higher energy or higher energy level or excited state. So electron jumps back to the lower energy level and emit energy in the form of the photons. Now energy of such photon, we know that the energy of the photon which is going from here to here is the difference of the energy level, E2
Yes,
minus
sir.
E1 or
Yes,
En2
sir.
minus En1. So this will be, so electron is moving from N2 to N1. So energy of the photon which is releasing, this E is the energy of releasing photon, energy of emitted photon. So this E energy of the photon is Sc by lambda. So you will get a specific wavelength because this value is fixed. This value is fixed. So lambda will have certain specific values only. So there will be only specific values of lambda. That is why you are getting the discrete or line spectrum. Are you understanding or not?
Yes, sir.
So this is the explanation why there is a emission spectrum. Why there is a emission spectrum. Now wavelength of the emitted photon. Wavelength of the emitted photon.
Photon.
Yeah. So wavelength of the emitted photon we can calculate very easily. We know that the photon, if the photon is moving from N2 energy level to the N1 energy level, so what will happen? the electron will emit photon.
Yes, sir.
It will emit photon, and energy of that photon is given by energy in N2 energy level minus energy in N1 energy level.
N1 energy.
Energy
Yes.
level. Okay. And energy of electron in nth energy level is given by minus 13.6 Z square divided by N square.
N square.
So in N2 energy level, the energy of electron will be minus 13.6 Z square divided by N2 square. Similarly, for N1 you can write. So energy of the photon can be written as hc by lambda, and energy in the N2 energy level, energy of electron in N2 energy level will be minus 13.6 minus 13.6 Z square divided by N square and
N
2
square.
square, and this will be again minus 13.6 Z square divided by N1 square. Now you can solve it. This is hc by lambda, and this is this will become positive, and 13.6 Z square you can take common. So 13.6 Z square you can take common, and you will have 1 upon N1 square minus 1 upon N2 square. Now from here you will get 1 by lambda, that is equal to 13.6 Z square divided by hc, and this is 1 upon N1 square minus 1 upon N2 square. Now this value 13.6 by hc, 13.6 divided by hc, this value is basically find out to be 1.09 into 10 to the power minus 7 meter inverse, and this is also known as the Rydberg constant. Rydberg's constant. Okay, so so instead of this 13.6 by SC, you can write R. So the formula for 1 by lambda, you will have RZ square 1 upon N1 square minus 1 upon N2 square. 1 upon N1 square minus N2.
1 N2 square.
Yeah. An electron is moving from N2 energy level to N1 energy level. N2 is greater than N1. Okay, and one thing you have to remember, 1 by R value approximately you can put 911 angstrom. 911 angstrom.
Armstrong.
After that, this formula you have to remember to calculate the wavelength of electron when the electron is moving from one energy level to
One
the
person to another.
Yeah.
Yes, sir.
So okay. Now after that, we have the spectral series. So before that, we will solve this question.
So can you just show the previous formula? This formula.
I will write that the formula is this.
Okay.
1 upon
1 upon lambda.
1 upon lambda is equal to
is
Rydberg
equal to
constant R, and the
R.
value of 1 by R is approximately is equal to 911 911, or this is
11
R Z
Armstrong.
square. 1 by N1 is N2 square,
And
1 by
N1
N1 square
N1
minus
square
1
minus 1
by
by N2 square.
So this formula we have to remember. Now we will solve this question.
Yes, sir.
Okay. So now find the wavelength of a photon when electron falls from n is equal to 2 to n is equal to 1, and this is for hydrogen atom. So n is equal to 2, n means n is equal to 2 to n is equal to 1.
So N1 is equal to 2.
Yeah, I am telling how to do this. First, you should write the electron is moving from N2 energy level to N1 energy level. So electron is moving from 2 to 1.
1.
So the value of N2 is 2 and value of N1 is 1. Okay, N2 to N1. So this is N2, this is N1. So now it's clear. So now
Yes, sir.
they are asking the wavelength, and wavelength, how you will find the wavelength? 1 upon lambda is equal to r into z square, 1 upon n1 square minus 1 upon n2 square.
Yes, sir.
Now, one thing, what will be the value of z? Z is the atomic number, and hydrogen atomic number
Atomic
is
one.
1.
1.
Huh. So 1 upon lambda,
Lambda is
it will
equal
become
to
r into 1 square,
1
and this will
square.
be 1 upon 1 square minus 1 upon 2 square. So you will have 1 by lambda, that is equal to r, 1 minus 1 by 4. So what you will have? This is r, and 4
So yeah,
minus
so
2
it
is
will be 3.
r into 3 by 4.
3. Yeah, 3 over
Yeah,
4.
you have to 3, it will be 3 by 4. So you will have 1 by lambda is equal to 3r by 4. So you can write lambda is equal to 4 upon 3r.
So
So
3
you can write this 4 by 3 into 1 by r.
1 by r.
1 by r is approximately equal to 911.
911. Yes, sir.
11. So if this is 911, sometime you can take this value as 912 also. Sometime you can take this value as 910 also. For the calculation purpose, I am telling. Otherwise, you
Okay.
cannot do the calculation.
Okay,
If
sir.
you will put the value of Rydberg constant, that is when you will put the value 1.09, so that will be maybe difficult for you. So you can put here 912. Now try to 3 3 is a 9
Yeah.
and
Yeah.
3 4 is a 12.
3 for the 12.
So it will become 4 4 is a 16, 1, and 4 3 is a 12. So
12.
1216 angstrom will be the. So you will get the answer in angstrom.
Yes, sir.
1216 into. So can you this question? Second question?
Yeah.
From infinity to, and here na, in this you will get 1 by infinity square. 1 by infinity square is 0.
0.
So this for this question we have to first read this spectral series. So this is very easy.
Okay, yeah. The Balmer
Spectral series.
Paschen.
Yeah, Lyman Balmer Pasten bracket fund. Okay. So basically, what is the meaning of these series? Basically, first, what is the Lyman series? So what is the meaning of the Lyman series? Lyman series is what? Lyman series is the range, not the range. Discrete value of wavelengths are there. There are some discrete values of wavelength or spectrum which are lying in the Lyman series. Which
Yes,
are
sir.
lying in the Lyman series, or you can say which is founded by the Lyman. Lyman is
Lyman.
was the name of the scientist. So basically, when the electron is moved from anywhere to n is equal to 1, from
Anyway,
anywhere to n is equal to
n is
1
equal to 1.
means, you can see when the electron is moving from n is equal to 2 to n is equal to 1. So what will happen in this process? When the electron will move from higher energy level to the lower energy level, it will radiate some energy,
Yes,
it
sir.
will emit some energy. Means it is emitting some energy, means for corresponding to that energy there will be a particular wavelength. So and so one wavelength we will get from here. For example, if the electron is moving from n is equal to 3 to n is equal to 1, so from here also we will get one wavelength, from here also we will get one wavelength. But basically those wavelengths are those series of wavelengths are the Lyman series, Balmer series, Paschen series, bracket series. So when
Yes,
the
sir.
electron is moving from any other energy level to n is equal to 1, that is equal to Lyman series. So what is the condition for the Lyman series? Electron finally move to n is equal to 1. And what is the condition for the Balmer series? From anywhere, from any other energy level, the electron should move to n is equal to 2.
Yes, sir.
This will be used, okay, for Balmer series. The n is equal to 2. N is equal to 2 means the electron is moving or electron is coming from any other higher energy level to n is equal to 2. For Paschen series, you can say n is equal to 3 is there. For bracket series, n is equal to 4 is there.
4.
Okay. Now we can solve this question. Okay, if suppose if they are asking the longest wavelength is they are asking, find the longest wavelength of the transition. So for the longest wavelength, longest wavelength will, when the longest wavelength will occur. See, energy of the photon is equal to hc by lambda. So this energy of the photon is inversely proportional to lambda. So, okay, so this you can write as delta E, change in the energy level, change in the energy. So this delta E is, what is the delta E? Delta E is the change in energy or
Yes, sir.
difference in the energy level is
Yes, sir.
inversely proportional to the lambda. If you want lambda maximum, this should be minimum. If you want
Okay.
lambda minimum, this should be maximum.
Maximum.
So for the longest wavelength, smallest transition means the transition from n is equal to 2 to n is equal to 1 will be the smallest transition.
Smallest transition.
And longest or the largest transition will be n is equal to infinity to n is equal to 1.
Yes, yes,
Okay.
yes.
This also we will use in this question. Okay, so find the shortest and the longest wavelength. Find the shortest and the wavelength, longest wavelength of a Balmer series
Of 4 hydrogen atom.
of a hydrogen atom. So for hydrogen atom, Z value is 1, and
1.
they are saying the Balmer series. So Balmer series, what is the condition for the Balmer series? Electron should move from any n2 to n is equal to 2.
2.
Means
Yes, sir.
n1 should be 2.
Yes,
Is
sir.
it or not? n2 to
Yes, sir.
n1 is equal to 2. Means finally the electron should move from n is equal to 2.
2.
Lyman, for Lyman, and with the n1, the n1 will be value, the n1 value will become 1. For the Lyman, for the Paschen series, what will be the value of n1? Lyman, Balmer, Paschen, and is n1 is will become 3.
3.
Understand? Na? So electron is moving from any n2 level to n1 is equal to 2 because of the
2.
Balmer, because of the
Balmer
Balmer series.
series.
Yeah. So this is given. Now, on the basis of this, we have to calculate the shortest and the longest wavelength. So now first see shortest wavelength. Shortest wavelength when we get, when the transition is smallest transition.
Yes, sir.
Smallest transition means the energy change in the energy should be smallest. So now come here, come to this. Now for the Balmer series, this transition is the smallest transition from n is
Yes,
equal
sir.
to 3 to n is equal to 2. This is the smallest transition means
Smallest
energy
transition.
gap. Smallest transition means energy gap should be minimum. So this will be the minimum energy gap, you can see. So what is the value of n2? 3. The value of n2 for this shortest wavelength will be n2 to n1. So
Yes, sir.
electron should move from 3 to 1. This will give you the shortest wavelength.
Shortest wavelength. Yes.
Okay. So now apply the formula. We can apply the formula. Okay. So no, 3 to 2. This is not 1. This is 2 because this is a Balmer series. So 3 to 2. Now we have the formula 1 upon lambda is equal to R into Z square. Z means 1 square.
Yes, sir.
And it is 1 upon n1 square. N1 square means 2 square minus 1 upon n2 square means 3 square.
3
So
square.
it will become 1 upon lambda is equal to R. This will become 1 by 4 minus 1 by 9. So it will become R 9 minus 4. This will become 5 by 36. So
Yes,
from
sir.
here we can find lambda. Lambda is equal to 36 by 5
36 5
into
to
1 by
9.
R into 1 by R, and lambda is equal to 36 by 5 into 1 by R. We can take 910. I told you now 1
Yes.
by R
Yes, sir.
we can take either
9,
911.
10, 11, 12.
Yeah. 910 angstrom also we can take. So 910 angstrom we can take approximately. So you will get 5 ones of 5 and 5 eights of 5 eights of and 5 twos are 10. So 182 into 36. So basically you will get the answer 6552 angstrom. So this will be the shortest wavelength. Longest, can you find the longest? So for the longest, for the Balmer series, we know that finally the electron should come to n is equal to 2. So if it will come from infinity to n is equal to 2, it will be the longest transition.
Yes, sir.
For the shortest wavelength, smallest transition. So now we want the longest. Just a minute. We want the longest wavelength,
Yes, sir.
longest lambda. So for longest lambda, the electron should have the largest transition. Oh yeah, we have done I think mistake. Longest wavelength. Basically, this will be the longest wavelength. Sorry. Why this is the longest wavelength? Because this transition is the smallest transition. Okay, this is the longest wavelength. Sorry for that. This is the longest wavelength. Why? Because this is the smallest transition. Now
Yes,
we will
sir.
calculate the shortest wavelength. Okay, this is the longest. Now shortest wavelength we can find. Shortest lambda. So shortest lambda means largest transition, and that transition will be from infinity to n1 is equal to 2. So n2 value you have infinity and n1 value you have 2. So you can apply this formula 1 upon lambda is equal to rz square 1 upon n1 square minus 1 upon n2 square, and you will get the value of lambda. Okay. Okay, Harsh, so now what you should do now? You should now take the screenshot fast.
Okay, sir.
Then in 5 minutes or 6 minutes, I will finish the absorption spectrum.
Done, sir.
Okay. Okay.
So I can scroll down.
Yeah.
Done, sir.
Here it will be Z double E.
Yes, sir. Zeeman effect.
No problem. Zeeman effect. Actually, it is pronounced as Zeeman effect.
Yes, sir. Done, sir.
Just a minute. I should zoom out. Now it's fine.
So I can scroll down.
Yeah.
Done, sir.
Okay. Explanation is important.
So I can scroll down.
Yeah.
Done, sir.
Okay. So Harsh, this chapter is finished.
Yeah. Okay, sir. Sir, I have a question for you, sir.
Yeah.
Sir, do you think it's possible to finish 13 chapters in 2 days?
30 chapter means if you have not studied, means if you are starting from the scratch, Means if you don't know what is electric field, if you don't know what is current, then it is not possible. If you
No, sir,
know, you
of course
know,
I know.
means you should say that is it possible to revise 13 chapters in 2 days?
Yeah, sorry, yeah, revise 13
Of,
chapters in
of
two
course, it is
days.
possible. To complete those chapters in 30 days, not possible. In 30, I will say in 2 months also, it is not possible. But to for the revision, it will be possible, of course. So you have to do 13 chapters of this subject, physics.
Physics.
Okay.
Physics is fine. When chemistry, I have 1 day holiday. What will I do
Okay.
in
Well,
that?
so means actually, I was saying that time 1 day will not affect.
Yeah, 1 day will
So
not be effective. So
means I want to say that now, have you prepared earlier? Means have you done
yeah,
all the
earlier I
all the
studied, but then I forgot, right? I forgot.
no
Earlier I
means
did.
you have did. So
Uh,
which means which part of the chemistry do you feel it is right now for you is weak?
sir, everything, sir.
Everything. How can it be possible?
Like
Or
I know the
organic.
things, but then I keep on forgetting it.
So it happens with everyone. With me also. With each and everyone is having the tendency to
My
forget the
concern
things.
is why would they keep model exam like 20 days before the boards?
So just tell me one thing. Out of there are three parts of chemistry: physical chemistry and
Yeah. Yes. Yes.
inorganic and organic.
Anorganic.
Which part you are thinking that will be most difficult for you?
Inorganic.
Inorganic. Because there are so many exceptions, so that's why.
Yeah. Organic is fine. You just learn the reaction.
Reaction.
Same thing.
Hmm. Okay, take the screenshot.
Done, sir. Can you scroll?
Yeah.
Second scroll down.
Yeah.
Second scroll down. Done, sir.
Okay. So now don't take stress. Means what you can do by taking the stress. Okay, it's all
Well,
fine.
nothing.
Means whatever you did means if you have studied well. I will not say if you have not studied, then everything will be okay. But if you have done the things properly, then it will be okay 100%. I am giving the guarantee of it. Taking the stress of exam, everyone takes. This is
Yes,
not
sir.
happening with you. The person uh, going to get the 100 out of 100 will be in the will be in the stress because of the exam. This
Yes.
is this is natural. This is not something which is not natural. If you
Yes,
will
sir.
not take the stress, means I am not saying take so much stress. Okay.
Like if you
If
don't text us,
if
there's something wrong with you.
yeah, that is abnormal. That is what I am saying. Taking stress is uh, not an abnormal thing because we are human beings and we all take stresses at different positions and different time zone.
Yes, sir.
So it is normal. Don't think too much. Okay, and whatever you have done in the last days or last days means previous months, whatever you have
Yes,
done,
sir.
you have studied, you made notes, you have given any test, and anything whatever you did, So definitely, if you have done those things with honesty, then it will reflect in your exam. Definitely. Okay. So taking means uh, occurring some stress during the exam is natural for everyone.
Yes, sir.
I am saying some.
Yes, some.
Okay. So it is natural. It's okay. Take it easy. Okay. And hope for the best. Okay.
Yeah, I mean it's pre-board, so it's
Yeah, it's
fine.
pre-board. Yeah. There are many other exams which are bigger than your board exams.
Yes.
Yeah. So don't think that the exams that you are going to give is like fighting the India Pak war. It is not like that. It will be simply the things you have done in your classes, you have done in your coaching, you have to write there. I know that there should be some stress, but that will not affect your uh, efficiency.
Yes, sir.
Okay. Okay. So absorption spectrum is very easy, and
Okay.
absorption spectrum. What happens in absorption spectrum? This is the some gas. Okay. And from this gas, white light is passed. Okay. This is some gas, and from this gas, white light is passed. Okay. And this is the prism. And now the temperature of this gas is less temperature. This gas is at less temperature, and we are passing the white light. Okay. And this white light is having the wavelength range from 400 angstrom to 800 angstrom. We
So
are passing,
4,000, right?
oh, sorry, 4,000 to 8,000 angstrom.
8,000 angstrom.
Yeah, it's 8,000 angstrom. And this is a visible light. White light,
Yes, sir.
visible light, visible.
Yes, sir.
Okay. So after this light will be transmitted from this, and that transmitted light, when you will pass from the prism,
Prism.
again,
It will form
huh,
Webgure.
it will no, it will not form Webgure. That is the thing we are studying. This is the absorption spectrum. Basically, when you will find the spectrum on the screen, you will find the
Yes.
spectrum on the screen. This type of spectrum means here is continuous, here is continuous, here is a dark band,
Oh,
here
okay,
is a
okay.
dark band,
Dark
here is a
fringe,
dark
yeah.
band,
Okay, yeah.
here is a dark band, here is a dark band.
Yes, sir.
Here it is found that some wavelengths are missing here. These wavelengths are missing.
Yes, sir.
All other wavelengths are present, but some wavelengths are missing in the absorption spectrum. What is in the emission spectrum? Some wavelengths are present,
Are there in the absorption spectrum?
are there in the absorption. We will connect later. First try to understand the difference in the emission and absorption spectrum. In the emission spectrum, only few wavelengths were present on the screen.
Yes,
In
sir.
case of the absorption spectrum, only few wavelengths were missing from the screen.
Missing from the screen. Yes.
And one more thing, one very interesting thing. Those wavelengths which were missing in the absorption spectrum will appear here. Means
Yes, sir.
those
That were
wavelengths which
that were
were.
there in the absorption emission spectrum will not appear in the absorption spectrum.
Yeah, very good, very good. So this is, and the reason is same for the absorption spectrum of also, because when the electron will move
Yes,
from
sir.
lower energy, you will give the heat. Electron will move from lower energy level to the higher energy level,
Higher energy
or
level.
or if the electron is at higher energy level, it will absorb some heat. Okay, okay. So it will absorb some heat, and it will move to the higher energy level, and there it will be unstable. And when it will be unstable there, it will move to the lower energy level, and it will release some energy, or it will emit some energy, and that energy will have some specific wavelength and range of, or those discrete wavelength pattern is basically the absorption spectrum that you are getting on your screen. So basically
Yes, sir.
here this type of this spectrum, you
Yes,
will
sir.
get the continuous
Continuous
spectrum,
spectrum with some missing
wavelength
wavelengths.
missing wavelength. Okay, now what is the reason? When you will give the white light, okay, when you will give the white light
White light.
again, so electron will be, suppose electron is at the ground state when you
Yes,
are
sir.
giving the white light. So this white light will have some radiation or some energy. White light is a radiation. It is having some energy. So this electron will absorb some energy, and it will move to the higher energy level.
Higher energy level.
It is now this time what is happening? This is absorbing uh, energy. This is
Yes, sir.
absorbing energy, and this is moving to the higher energy level, and the energy of the photon when it will return back from here to here, that energy of the photon will be given by this energy level minus this energy level, hc by
Yes,
lambda.
sir.
And this
Yes, sir.
lambda will be specific because this value will be fixed value. Okay, so you can
Fixed
say
value.
here no the specific wavelength that appeared in the emission spectrum, those some wavelengths are missing in the absorption spectrum.
Yes, sir.
Basically, actually, what is happening? This is white light, and
Yes,
white
sir.
light means light is made up of photon.
Photons.
So this time, this electron is absorbing photon of a specific
Photon.
wavelength.
Yes, sir.
Absorbing photon on a
Photon
specific wavelength. That is why some wavelengths are missing here.
missing.
So now you can take the screenshot of this, and this chapter is finished. And will you join the next class?
On Sunday. Sir, on
Yeah,
Tuesday.
on Sunday, if you are free, then you can
Sir,
join.
because next week
Mhm.
all my exams are like one day gap. Like next week I have physics, I
Yeah,
have chemistry, I have bio.
yeah.
Like one day gap. Like I don't even
Okay.
have time to study for that.
I can understand. So, okay, we will see. And but uh, after this, I am telling you, there is a requirement of 4 lectures only
Yes, sir.
to finish the syllabus. 4 lectures,
Okay, sir.
because the next chapter, that is the nuclei. It will take two
Yeah.
lectures, and next chapter, that is the
Yeah.
last chapter, the semiconductor. It will also take 2 lectures.
Semiconductors. Sir, two chapter.
So,
Yes, sir.
semiconductor. Sorry, semiconductor. It will
Second
also
slow
take two. Yeah,
two
it will
lectures.
take
Yes,
two
sir.
lectures. So if somehow you can manage 4 classes, then it will be fine. Otherwise, you should go with your time, and it will depending upon you. No problem. Okay.
Yes, sir. Second school, no?
Yeah.
Done, sir.
So now, when will be your next exam?
Sir, Sunday.
On Sunday. So,
Sunday and then Tuesday I have chemistry and then Thursday I
uh,
have biology. So I don't
okay.
have
Yeah.
any gaps.
So when these exam will be finished,
Sir, 12th
and
February.
your final exams will be started on
24th, sir.
24th. Okay, so how you will continue with the class? I don't think that you will continue.
Uh, I'm also thinking about that, sir, because I don't have time. I literally
Yeah.
don't have time.
Okay,
I mean,
so
it's not, I think it's like the school kept in this situation. I can't do anything. Like
no
practicals are also
problem.
kept late.
Yeah, it's fine, it's fine, no problem. First, your exams are important, and your time is also important. Okay.
Yes, sir.
Okay, so if there will be the